Hello everyone, my name is Ranjit Biswal. I am a data science trainee at AlmaBetter. This is my second project, Yes Bank stock closing price prediction. Yes Bank is a well-known bank in the Indian finance domain. Since 2018, it has been the news because of the fraud case involving Rana Kapoor. On to this predict fact, it was interesting to see that important the stock prices of the company and whether time series models or any other prediction models can do justice to such situation. The dataset monthly stock prices and the bank since its inspection and include closing, starting, highest and lowest stock price of every month. The main object is to predict the stock's closing price of this month. First of all, what is stock? A stock or share, also known as a company equity, is a financial instrument that responsive ownership in a company. Since we have the Yes Bank stock price dataset, which has the monthly stock price of the bank, since its inspection, it contains the following features: date, open, high, low, and close. Close refers to the price of an individual stock when the stock exchange closed for the day. Open means the price at which stock started trading when the opening bell rang. Date, it denotes date of investment done. High refers to the maximum price in given the time period, and low refers to minimum price in given period. First of all, I import some library for data handling. Import pandas as ed, import numpy as np, from numpy import math, from xgboost import xgboost. Import library for data visualization. Import matplotlib pyplot as plt, matplotlib inline, import c1 as sns, machine learning libraries. From sklearn processing, import min max scalar standard scalar. From sklearn model selection, import trend test suite, grid search cv. Then from sklearner model, import linear regression, read lasso logistic regression. Then from sklearn tree, import decision tree regressor. From sklearn import random forest regressor. From sklearn matrix, import mean square error, r2 square, mean absolute error, mean absolute percentage error. Import warning, filter warning, ignore. Read data. First of all, I read the data set opening, highest, lowest, and closing prices of stock in every month. For this analysis, we select only closing stock prices. First, I connect Google Drive. Then I mount my drive. Then loading CSV data, a pandas frame. Def is equal to pt.read CSV. Then print first row for this data set. Date, open, high, low, and close. Then I do some data processing. Then I do data available there 5 to the 20, and I save it 185 column and 5 row details of data set. Then we will change data types from that data and line. Describe includes 185 count, unique 185, top January. Visualization of Yes Bank stock. Then I visualize this Yes Bank stock. This stock since June 5 and November 13 still open and down, not growthly quickly. Then November 13 to its growth highest for February 20. Then I describe this data and I see this result. Then I count some missing value. There are no missing value. I don't found any kind of missing value. Then I check null value. There are no missing null value in this data set. Then I see some duplicate row. There are also no some duplicate row. Feature engineering on data set. Then I do some feature engineering data set. It's in date and open price and high price and low and close price for a particular date and time stock prices. Then I Processing data finished. Data set is clean, ready to exploit the data analysis. Exploit the data. It's the stock price of Yes Bank stock prices. 2005 to its start, and still growth of 2014, its increase and decrease slowly, and 2015 to 2019, it's mostly highly stock prices. As you can see, their stock price decreased after 2018. The probability because of Rana Kabur cash in hit the stock price heavily. Let's visualize the close, open, low and high in combined line plot. Its close line in green color, then open, low and high. It show all are all correlation each other is very similar to each other. All price show almost similar trends with each other, which means that these features may be strongly correlated with each other. Distribution of dependent variable, close price of stock. Then I make a list of independent numerical variables. Its low price and high distribution is, so this is the closing price and destiny. Distribution plot of closing price is right skewed. To make it normal distribution, apply log transformation. Then I apply distribution of closing prices. After log transformation, distribution of closing price is more normal. Distribution of numerical features high, low and open price of stock. This is the output. All numerical features distribution are right skewed. Apply log transformation, it's make normally distributed. Then plotting distribution each other numerical features by applying log transformation. Then I apply some code for visualize this data, and I see correlation of each other is very similar. Now we have normally distributed numerical feature. Then I see some data correlation each other is very strong and very good. All data correlation similar with each other, and our correlation 0.98 out of 100. Then I do some heat map for see this correlation 1 and 0.99, 0.98, 0.98, 0.99, 1, 98, 0.98 and 0.99. All correlation with each other very similar, no much gap, all variables show high correlation with each other. Then I show you some box plot visualizing. It's also same correlation with each other. Then I recalling update and transformation. Then I do linear regression. Linear regression value is 0.994 actual linear regression model, and then I test accuracy for linear regression model 0.99.8. Then I do evaluation metrics for linear regression. This is MSE value is very high and R2 value is very low, like 0.998. Then I do linear regression actual versus predicted. Then its actual value and its predicted value. Actual value and predicted correlation with each other very good, and it's no more high correlation with each other. And it's the lasso regression. From a scale linear model input lasso, then I do some lasso regression, and accuracy of lasso regression model 0.99.4 and predict of the data. And evaluation matrix, its MSE value is very high, 20.427, and R2 value is 0.998. Then I do lasso regression, actual value was predicted. This is the actual value and this is the predicted value. Also there are correlation data with each other very similar. Then I do cross validation on lasso regression. Cross validation value is IMSC value is very high, 19.996, and R2 value is very low, 0.998. Then I do lasso regression after validation versus actual predicted value. This is the actual value and this is the predicted value. Actual and predicted value correlation with each other very good after lasso regression after saving. Then I do ridge regression. Ridge regression value is 0.994. Accuracy of lasso regression model. Then I do ridge regression actual versus predicted price. This is the output of this graph. Then I do cross validation of ridge regression. Evaluation metric of ridge regression after validation. MAC value is very high to 20.095 and R2 value is 0.998. Then I do ridge regression after validation actual versus predicted. This is the actual and predicted. Close price ridge regression after CV. These correlation with each other. No, very good. Then I do elastic net. For elastic net, accuracy of lasso regression is 0.945. Then I do prediction of data, and this is the output. MAC value is 436.358 and R2 value is 0.95. Then I do elastic net was actually predicted. This is the output. It shows just some similar definition with each other. Then I make decision tree regression model training without any parameter. Then its value is 1.0 and decision tree regression accuracy in testing data is 0.9930. Then actual price was predicted price ridge regression after validation of plotting. This is the plotting value. Actual was predicted. Then I do cross validation on elastic net. Hyperparameter tuning for elastic net. This is the output of elastic net after validation. MAC value is 20.99 and R2 value is 0.998. It's very good output of R2. Then I do elastic net after validation. This is the elastic net of after validation. Then I do hyperparameter testing. This is my hyperparameter testing output. Check accuracy score with grid search CV. It's 0.9823 and then I do decision tree regressor, decision to regressor, decision tree score, decision tree best parameter and testing score of best parameter score. Then I do random forest. Random forest do training on the random forest. Accuracy score of random forest regressor without any parameter is 0.997 out of 1 point. Is very good parameter of random simulation value. Then I do evaluation matrix complex and implementing for XGB boost. XGB boost R score, R2 score value is 0.99 and R2 score trend value is 0.9943. Then I make this model for all model value. This is the lasso regression model and lasso value, ridge value, elastic net CV, decision regression T and random regression, gradient boosting regression and XGB regression, all value. Then finally I got some conclusion. We got a maximum accuracy of 99%. Linear, lasso and ridge regression show almost same R square value, where elastic net models show lowest R square value of high RMAC and MAC and MAP, and then close open and high price stock are strongly correlated with each other. Regression models, namely random forest regressor, XGB boost regressor are built. Then I show my PPT. Team note. This is our also Capstone project 2. Yes Bank stock prediction, price prediction is our subject. My team name is Incredible Data Science. Team member me also Ranjit Biswal and Subhendu Dev and Abhishek Kumar. Then we create some contents: introduction, data summary, excluded data analysis, data prediction, data pre-processing, correlation matrix, model training, hyperparameter tuning, summary of all ML models, then conclusion. Introduction. To determine the Yes Bank stock future value on the National Stock Exchange by making machine learning model of linear regression, the advantage of successful prediction of stock future price could result in frequent profit. The efficient market hypothesis recommends that stock cost mirror all right now accessible data and value. This is the Yes Bank stock value. Then expert data analysis by EDA. At this stage, we conduct an EDA on the selected features in order to better understand their spared pattern and relationship with other features. It gives us an instruction as to what is going on the dataset. We can see that the given dataset of Yes Bank stock price is not normal distributed. It looks like skewed, which makes our regression models difficult to learn pattern of the dataset. So we need to apply some transformation techniques like loss transformation, scalarity, etc. to make the dataset normal distributed to make our model easy to learn and pattern the data. Then I make some dataset. Data summary. We have Yes Bank operational store data. It's following some features: open, high, low, close, and data. Not close will be our dependent variable and other will be independent. Then relationship between independent versus dependent. Independent by dependent correlation each other is very good or very similar with each other. Then I make some heat map, correlation heat map. All variables show high correlation with each other. The heat map helps us visualize the correlation of each other params with respect to every other params. The sets changes from the highest and lowest correlation with each other. We can see the matrix on this slide of dependent variable close by is highly correlated with all the other independent variable. Then I do some linear regression, and this is the linear regression output, and R2 value is 0.9928. And ridge regression. Ridge is a L2 ridge regression, the penalty time of alpha, where alpha value is square of what? Here R2 is about 0.9923, which means models independent. Feature is able to describe 99.23 of a dependent variable. Our adjusted R2 score of decision tree is 0.9911. It means our random forest is 99.11. It means there is no change in prediction even after closing validation of CV. Then lasso regression. Lasso is all regulation in lasso regression. The penalty term alpha is absolutely value of words. Here R2 is about 99.28, which means model and institutor features is able to describe 99.28 of a dependent variable. Our adjusted R2 score for decision tree is 0.9916. It means our random forest is 99.16, correct fit in our model. Then I do elastic net. This is the elastic net output. Also I saw this in my previous column note. Or here is about 0.96. It means model independent features to describe of our adjusted R2 score for decision tree is 0.963. It means our random forest is 96, correct fit of this model. Then decision tree. Decision tree regression trains a model in form of a tree predict data in the feature of generates useful contents output by observing the property of an item. A decision tree is a non-pandemic supervised learning algorithm which is unauthorized for both classification and regression tasks. It has a historical tree structure which contains of a robot nodes, branch, internal nodes, and leaf nodes. Here R2 is about 0.9764, which means model independent features is able to describe 97.64 of a dependent variable. Adjusted R2 square is a correlated goodness of fit model accuracy. Measures of linear model, it defines the percentage. Then I do random forest. Random forest is a commonly used machine learning algorithm trademark by Leobran and Adel Coulter, which combines the output of multiple decision trees to reach a single result. It else of and flexible have floored its adoption as it handle both classification and regression problems. Here R2 is value 0.968 and XGBoost. Extremely guided boosting is an open source library to provide uncooperative and effective implement of gradient boosting algorithms. Other open source implements of approach XGBoost before XGBoost. The release of the XGBoost approach to almost powerful technique and model applied machine learning community takes of gradient boosting more generally. Then evaluation metric. Here is all value, linear regression value, and R2 value, ridge value, lasso value, and elastic net value, then decision tree, random forest, and gradient boosting regressor, and XGR booster. All values are here. Then finally, conclusion. Target variable is strongly dependent on independent variables. We have seen that in our SBank dataset there is no null value and no duplicate values are present in this dataset. We have one feature name is date, which is object type. So we need to convert this into data format and apply some features engineering models. With the help of distribution plot, we see that our data is procedurally skewed. So we apply some kind of transformation, log transformation to convert into it a normal distribution. Lasso and regression models are given the same result approximately. Then we have see implemented cross validation on different algorithm as CV platform better on small data set, but the result is nearly same. We got a maximum accuracy of 99%, linear ratio and ridge regression show almost R square value, where elastic net model show lowest R square value and high MAC, RMAC, MAE and MAP. Then close, open and high price of stock are strongly correlated with each other. Then regression models, namely random forest regressor and XGBoost regressor are built. That's all about this project. Thank you, AlmaBetter, and thank you all for giving me this project.